Hi everyone! Tonight we're going to learn about fossils, and we're going to quickly go through the different types of fossils so that you can be able to tell them apart as we get farther into chapter 6 in your textbook. So here we go. Alright, what is a fossil? Well, it can either be the actual remains of an animal or plant, or it can be evidence that the animal or plant was there. And then geologic processes come in and replace whatever part it was. Like if it was a bone, it would replace that bone with rock. So most of the fossils that you find kind of around our area that are found in rock are actual rock, but it's just where rock has filled in where the bone used to be or where that plant used to be. So we have fossils that are in rocks, and hopefully that rock on the right side looks familiar to you because that is fossiliferous limestone. You guys have seen that when we talked about sedimentary rocks. Now that's when you have organic material that gets put together into an organic sedimentary rock. We also have fossils in amber. Okay, amber is tree sap. So it's actually really expensive when used in jewelry because the insects that are now either endangered or extinct got stuck in that tree sap and were literally preserved. So this is not where rock has come in and replaced it. It's where you actually have the preserved specimen stuck in the amber. So the more rare the insect is that's stuck in the amber, if that amber is used in jewelry, then the more expensive the piece of jewelry gets. Petrifaction. So you might have heard of petrified wood. Anytime you have plant or animal material that decays away and then minerals come in and replace it, that's what petrifaction is. So a lot of times with trees or tree stumps, this will happen out west in Wyoming. You'll find it quite a bit. And it's just where the actual tree, the wood, has worn away or decayed away, and then the minerals came in and replaced it. So it's actually very hard, like rock would be, but it's just made of minerals. And then we have fossils in asphalt, which are very similar to the insects that get stuck in the amber, but on a much larger scale. So the tar pits is basically tar asphalt pools, and ancient creatures like the woolly mammoth would get stuck in these pools and not be able to get out. And much like the amber, it's the tar would surround the animals and it would preserve them. So that's the actual preserved specimen, and it's not rock coming in to take the place of this one either. We have frozen fossils. So you guys probably know already that anytime something gets buried in ice, it's going to preserve it. That's why we put food in the refrigerator, because the colder you keep it, the longer it's going to stay preserved. So the woolly mammoth in particular, which was up in the Arctic, would migrate and it would get buried in things and the snow would cover it. And so there have been multiple occasions where they have found mammoth tusks, which you see on the top right side, or they've found full woolly mammoths that they have uncovered, hair included. They basically are elephants with long hair, and they don't exist anymore, but they have found preserved woolly mammoths buried in the snow. What you see on the bottom right is a baby woolly mammoth that they actually found buried in the snow. I believe that one was out of Siberia. And then we have trace fossils. Trace fossils are evidence that an animal's been there, but the actual animal or bone is not there. So it's something like a footprint where you can tell that the animal had passed through that area. It could be scat, which is basically feces of the animal, for lack of a better word. That you can tell what the animal ate. You can tell all about their diet by picking it apart, but it's not actually a piece of the animal. So a lot of times you'll see things like dinosaur footprints that are evidence that the animal was there. You can tell what their foot looked like, the claws, how many, quote, fingers or toes it had, things like that, but you don't actually have the animal there. Okay, molds and casts. A couple more things to go over for you. A mold is basically an indention in the rock where the fossil was pushed into it. So it goes in. So it would be the picture on the right side that you see below. A cast is basically a 3D mold that comes out of the rock. So that's the picture that's on the left side. So you could actually put them together and they would fit together perfectly. But you just need to know the difference between a mold and a cast. A mold goes inward where it's been pressed into it and left an indention. And then the cast is actually the three-dimensional piece that's coming out from the rock. Okay, so what's the point of having fossils and why do we search for them? Obviously, we want to know about our history and we want to know about what the ancient creatures were like. So that's just interesting in itself. But it also gives us evidence of our environmental history and how our environment has changed. For example, we have found marine fossils. That's fossils of animals that have belonged in a water environment. And they're found on mountaintops. And that doesn't make sense. But what that told us is that at some point that mountaintop, that rock, had to be below sea level where it was covered by water. So something had to happen to push that crust of the earth up into the mountain. Tropical fossils found in Antarctica. That doesn't make any sense because Antarctica is cold. So that told us at some point Antarctica had to be located closer to the equator, which it happened to be way back when we had Pangea going on, which we'll talk about when we get to plate tectonics. But it showed us that Antarctica had moved. Because there's no way that tropical fossils could be found in an area that was frozen. There's just no way that it was a plant fossil, and there's no way those plants could grow in a cold environment when they're tropical. The other obvious thing that fossils show us is how organisms have changed over time. So we can track if they have basically adapted their body or they have adapted to survive in different environments. And the last thing, index fossils. These are fossils of creatures that we know for a fact only existed for a very short time. So if we know that that creature existed 250 million years ago, then anytime you find it in a rock layer, you know that that layer is 250 million years old. So it kind of helps us absolute date the different rock layers that we uncover. So you have some examples of major index fossils that we use quite frequently. One of them is called an ammonite. We know that if we find an ammonite, anytime we uncover a rock layer with it, that rock layer is 208 to 230 million years old, because that's when the ammonite lived. The trilobite, again, lived 400 million years ago, so we know that if we uncover one in a rock layer somewhere, that rock layer has to be 400 million years old. Okay, make sure your notes are filled in and then bring them to class to be checked for homework. Have a good night.